we are given a question to answer. Now ideally these questions should be answered using a statistical calculator. However, since there are various calculators available, number one, and every calculator has its own way of using the different keys to get the results, and also because Microsoft Excel, which we are using in this video, is much easier to display for you on a video format what we get as the answers, we would rather stick with Microsoft Excel. However, if you have a calculator, you are more than welcome to double check your answers, do the calculations and double check your answers using the calculator, making sure that you understand the inner workings of the various keys and commands on your calculator, and see if you get the same answer. Now we have the question that the yield per hectare, the value C that we have there, is determined by the rainfall in May, which will be the M values. So we have farmers who believe that when you have the values for the rainfall in May, you can dictate, or you can actually predict the yield per hectare, the harvest, the amount of harvest that you get per hectare from the values that you get for the rainfall in May. And then 9 farmers recorded data as follows, which we already have on the screen. The first question that we have to answer then is to determine the equation of the relevant regression line. So what we'll do then is to select all of this data, create a chart, and then once we've got a scatter chart, and once we've got that, we will just add a trend line using the tools from Microsoft Excel, and we will then get the chart like that. Then they say, the next question, determine R, the linear correlation coefficient between C and M. Now we have the equation given to us already by Microsoft Excel, that line there, the linear fit line, y is equal to 0.6077x plus 2.4813, and then we have the coefficient of determination, r squared, given us 0.3516, also by the computer. We need to work out not r squared, which is obviously still given to us, we need to work out r. And to do that, we'll simply take the square root of that value, 0.3516, and we'll get a value of 0.5929. And then they say, once we've got this, do the farmers have grounds for their belief? Supply a reason for the answer. No, because the value of R is 0.59, it's just over halfway to 1. It's not very close to 1, so therefore this is not a very good fit line for the data that we have. Looking at the R squared value, the 0.35, multiplying that by 100 will give us 35% of the data on our graph can be accurately determined by that fit line. Only 35% of the data. The other 65% of our data is lost outside of the trend line that we have by that equation. So this is not a very good approximation then. And then the last question, another farm had an average rainfall in May of 14.6 millimeters. Give the estimated yield of the harvest. Correct to 1 decimal per hectare, which obviously means we have to work it out algebraically, but before we do, you can try and pinpoint it by going there to approximately 14.6, moving all the way up to the trend line, and then coming across, and you'll see it will be in the region of between 11 and 12. We'll get the yield predicted by that trend line, and then just to work it out algebraically and correctly, you'll take the 14.6, which we have said in this table. We have selected the M values when we created the chart. We selected the M values as the X values and C then as the Y values. So that's why we've got 14.6 on the X axis. So then you'll substitute 14.6 into X there, multiply by 0.6077 plus 2.4813, and you'll get an accurate value of 11.35. Now they specifically said we need to give it correct to 1 decimal, so it will be 11.4, which confirms our theory that it would be around there. So 11.4 would be the predicted yield for this the next farmer if he had a rainfall there of 14.